Hello, Lisa. This is Mr. Moore, and I wanted to share some information to help you be prepared for Dr. Liao's class on Monday. And as I mentioned in the Canvas assignment, this is something we're trying out. I want to see how it works, how you feel about it, how Dr. Liao feels about it, how I feel about it. I think this is where it is a good place for you to be. We'll be doing some review activities, things that you already know, things where I've been giving you other assignments because you'd be bored listening in on it. You're still going to be in my class. But the idea is once every week, maybe once every 2 weeks, you sit in on one of his lectures when it's appropriate, when you'll be able to kind of follow along with one of the lectures he's doing to learn some more advanced things. And if necessary, I might give you some information ahead of time to help you prepare for that class with things you need. So all of this builds on the work you've been doing on slope. I gave you some special problems on how to find the slope of a curve by using the equation for the slope between 2 points on a curve and letting them get closer and closer and closer to each other until we get the actual slope at a point. Whoops, that's not it. This is it here. So here we have a curve. I'm getting ahead of myself here. Y equals x squared. And you found the slope as we approach the point 3 comma 9. And you find that that slope approaches the line y equals 6x minus 9. You did that by putting in another point x comma x squared and 3 comma 3 squared, find the slope between them, and you find the slope at that point. That's called taking a derivative. That is calculus. We're going to do that with every function, and you've done this in a bunch of them already. What we're going to show next is, hey, what is the derivative? It's just finding the slope of the curve. At a particular point, you plug in x and c, you find the limit as you get really close to 0, and in this case, you found the derivative, which can be written as y prime. That little tick mark there means prime, or you read it as prime, or dy dx, which means the rate of change of y with respect to x, is 2x. If I have the curve y equals x squared, at x equals 3, the slope is 2 times 3, or 6. If x equals 0, the slope is 2 times 0, or 0. If x is 100, the slope is 2 times 100, or 200. Using the method that we used for every single function would be very tedious. So the good news is there's a whole bunch of shortcuts that they came up with. And here's the first one. If we have any function y equals x to the n power, the derivative is just n times x to the n minus 1. If I have y equals x to the 4th power, the slope is 4 times x cubed. If I have y equals x to the 3rd power, the slope is 3 times x squared. And this also works for negative exponents and fractions. If I have, I'm going to scroll here a bit, y equals 1 over x cubed, that's x to the negative 3rd. The slope is negative 3 times x to the negative 4th. If I have y equals the square root of x, which is x to the 1/2, the slope is y prime, or the derivative of y, is equal to 1/2 x to the negative 1/2. That says negative 1/2 right there. You can use this to put together the derivative of any polynomials because you can break them into parts. If I have y equals, I'll write this one out, y equals 2x cubed minus 4x squared plus x minus 3. The derivative of x cubed is 3x squared times 2 is 6x squared. The derivative of x squared is 2x times negative 4 is minus 8x. Derivative of 1x is just 1. And the derivative of 3x to the 0 is 0. The slope of a constant is just 0. And there's our derivative. We can do it just one piece at a time. So here is a list of all the rules for all the different functions you may ever have heard of. And I'm going to highlight this here in a minute. I'm going to zoom in a bit, or zoom out a bit, I should say. All right. We have constants, x to the n. Here's exponential functions and logarithmic functions, which you might not have covered yet. I'm not sure if you have. Trigonometric functions, cosine, sine, tangent, all those functions, their derivatives are listed here. You don't have to know how to get these. You just have to know, hey, this is the derivative of this function. And the thing that Dr. Liao will be covering on Monday is the derivatives of inverse trigonometric functions, which are these 6 right here. I want you to print this out and bring it with you to class. And these are the derivatives. If they give you the derivative of sine minus 1 of x, which is the inverse sine of x, it's 1 over the square root of 1 minus x squared. And you're done. These other ones are similar. most of Monday's class, I think, is going to be applications of derivatives. We'll get to that in a minute. And so you can rely on this table. If you were taking calculus, you'd memorize this table. You'd know this for the tests. But right now, you just have to have this available during the class. So print this out, have this ready. Here's another version of some of these that organizes them into groups. I kind of like this version. And you can also say that in this version, d dx of x to the n equals n times x to the n minus 1. Exponential functions, logarithmic functions, trigonometric and inverse trigonometric functions, they're all listed here as well. One other thing I want to mention, and this is also available in Canvas. You can print this and the other one list out from Canvas. If you have a function raised to a power, like let's say it wasn't just x to the 7th power, but I had 2x plus 1 to the 7th power. I can still use the same method to take the derivative. Just notice at the end of all of these, it says du dx. You have to multiply by the thing inside. And let me explain what I mean by that. So here we have a function 3x plus 1 to the 7th power. Well, I don't want to have to expand that out. That's a lot of work. But I know that the derivative of x to the 7th power is 7x to the 6th. So let's just assume this is, let's call u this inside. And I can say that the derivative of this is 7 times 3x plus 1 to the 6th power. That's our next line here. And then I multiply by the derivative of 3x plus 1. The derivative of 3x plus 1 is just 3. And I can do this all in one step. It's 7 times this thing to the 6th times 3. If the inside is more complicated, like here it's 3x squared minus x plus 1, same thing. It's 7 times that to the 6th power. And then I'm going to multiply by the derivative of this inside. That's going to be 3 times 2x minus 1 plus 0, 6x minus 1. And this is your answer. You can just get it in a couple of steps. So that's what you're going to be doing. You're going to be doing that with the inverse trigonometric functions a little bit. And then they're also going to be covering some applications of derivatives. So why do we want to find the slope of a curve? Well, let's go back to Desmos for a minute. I'm talking too fast. I apologize. Let's go back to this function over here. Here we have y equals x cubed minus x. And you'll notice if I zoom in on this, that it has a maximum and a minimum value here somewhere. Historically, we had no way of finding exactly where that min or max value was unless we use a calculator or a tool like Desmos. But now that we know calculus, we can figure this out manually. How do we do that? Well, we're going to plug in, I'm going to copy this image over to the whiteboard. Here's our curve. We know the function is y equals x cubed minus x, and we're trying to find out where this max and min value. Well, if y equals x cubed minus x, what we're looking for is the place where the tangent line is horizontal. What's the slope when the tangent line is horizontal? The slope will be 0, both here and here. So let's take the derivative of this. What's the derivative of x cubed minus x? 3x, x to the 3rd power, the derivative is 3 times x to the 2nd, minus x to the 1st power, that derivative is 1. And we can now figure out where the slope is going to be 0. 3x squared minus 1 equals 0. X squared equals 1/3. X equals square root of 3 over 3. And if I plug this back into the original equation, I get y equals square root of 3 over 3 cubed minus square root of 3. Oh, I'm sorry. I forgot the plus or minus here. Plus minus over 3. This is going to be for the positive x value, square root of 3 over 3. And I get, let's see, it's 3 square root of 3 over 27. That's square root of 3 over 9 minus square root of 3 over 3. Square root of 3 over 9 minus 3 square root of 3 over 9 equals negative 2 square root of 3 over 9. Let's go back to Desmos and check that. If I write the equation, x equals 2 square root of 3 over 3. There's that line there. And let's add the next line, y equals negative 2 square root of 3 over, keep putting that slash in there, 9. What do you know? They meet exactly at this intersection point, which is the minimum value of this function. So that's what you're going to do. And there's some links in Canvas that show you some things you can review to get ready for this. I'll add another link, and I'm going to add a link to this video. I hope this is helpful. Have fun on Monday. I hope it's an eye-opening experience, and an opportunity to learn something new that you haven't had a chance to before. And let me know how it goes. Have a good weekend.